Okay, given an array in one operation, you can choose a pair of index ij's such that okay, ai greater than aj, and remove the element at index j from the array. After that, the size of the array will decrease by one, and you repeat the order. Repeat and the relevant order of the element will not change. Determine the maximum number of operations that can be performed on the okay. So 2 0. Actually, have to find the maximum uh, non-decreasing, sorry, decreasing sub array. Hmm. So how can I do it? 3, then 1 can connect to 1. Okay, it's something like that, DB kind of stuff actually. Mm, mm, N is only 100, if I'm not wrong. Yeah. I think I should put 1 actually. No, it should be 0. 'Okay, failed. Oh, okay, I did a mistake here. 2 0 0. It says 1 0. Okay. Okay, it finds 1, it finds 0, it finds 0, it finds 1. So Okay. Oh, I can remove. Okay, it makes sense. Okay, I actually don't need db actually. If I can remove any value, yeah, I can just do a brute force kind of stuff. I just okay, you are given a binary string a as containing at least one. You want to obtain a binary string of the same length consisting only of ones. To do that, you can perform the following operation any number of time. Choose a number. Bro. Choose a number d and consider the string t as the psychic right shift of the string uh, s by d, or more formally t equal to uh, n minus d. Okay, after that, for all j for which tj equal to 1, perform sj equal to 1. That describes this. I didn't get it. Consider a number d and consider the string t as the cyclic right shift of the string s by t, or more formally t equal to s n minus d plus 1 up to n 1 to n minus d. Okay, after that, for all j for which tj equal to 1, perform sj equal to 1. Okay, the describe operation cost d coin, where d is the chosen shift amount. Okay, running. Okay, you need to determine the minimum number of coins that can be spent so that the string contain only once. Okay, I think in the third example, I think I got it. What it says, 101. Okay, consider the third example. Third one. Okay, this one. 1001110. Okay, in the stress case, it is optimal to choose d equal to 2. Then if I chose d equal to 2, just this will come first. uh yeah, this will come first. 10, then 01. Am I right? Yeah. Okay, then I'll set this to 1 and also this to 1. Only size of 2. Yeah, got it. Got the question. Okay, let's say I have some string 1100. Okay, if that's 1, I have to take at least 3 values. Okay, so I can make this one also 1. in 3. Then those are ones, so D, D from the end. So okay, not this one. So it will gonna be 1. Then I'll choose again D. So then it will gonna be 1. Then I can choose the okay smallest amount. 1 0 1 0 1 0 1 0 1 0 0. Okay, it does only in 2 shift. After, you need to determine the minimum number of coins that can be spent so that the string consists only once after all operation. Then this D coins, where D is the chosen shift amount. Note that the position j in the string, which initially s equal to 1, remain equal to 1 even t is equal to 0. That makes sense. D equal to only, okay, D equal to only 2, so it will gonna 0 0 1, this one 1 0 1 0. It doesn't make sense. 1 0 1 0, then 1 0 1 0 1. J equal to only, answer equal to only 2. Yeah, 2. Okay, 2. So it will shift by 1 0 1 0 1 0 1 0 1 0 1 0. So it's gonna become 1 1 1 1 1 1. All 1 other than this last one. So I have to shift once more. Okay. Okay. Note that each operation on the string T is performed on a fresh various n string. That is, if s equal to then after a shift d equal to 1, the string becomes s 110. After the shift d equal to 2, it becomes, okay. So I'm thinking 2e5 operations at max. Always doing single operation is uh, good. I think optimal. Always doing a single operation is optimal. Just shifting single one by one is always optimal, because if I do a single shift, I'll put 1 2 3 4. It will gonna be something like 4 1 2 3. Then if I do another shift, it will gonna be 3 4 1 2. It's same as if I want to do two shifts. So 3 4, yeah, 3 4 and 1 2. Okay, it's same as doing two shifts. So doing single shift is always good, single one by one shift. But problem is the value is 2e5, 2e5, and it's 2e5. So if I have 1 0 0 0 0, it will, let's make a less, okay, shift once and then 0 1 0, okay, then 0 1 1, 0 1 1. Okay, it will take an shift at most. So that's a problem. If I do some kind of brute force kind of stuff, that's a problem. Okay. 1 2 3 4 5. Okay. First shift it will gonna be 5 1 2 3 4. Second shift it will gonna be 4 5 1 2 3. Third shift it will gonna be 3 4 5 1 2. Fifth shift it will gonna be I don't need fifth shift. I can easily say all are okay. Okay. 5 4 3. Let's say this one 1 1, yeah, this one 1 0 0 1 0. Okay, so in fast operation 4 will gonna be 1 easily, 1. Okay, in second also 3 is already 1, and 1 is already 1, and 5 will gonna be also 1. So in second operation, anything connected to in second operation, I can say only 2 isn't 1. In second operation, 2 will also gonna be 1. Not 2, actually 3. Okay, it was wrong. Not 3 isn't 1. 4 is 1. 5 is 1, and 1 is 1. 1 4 4. Because of 4, 5 is also 1. Doing single operation is always good. 3,000 people already solved it. single operation. Doing single operation is always good. It will have 5 4 3, 5 4 3. It will have 1 5 4. It will have 2 1 5. So I'm saying let's remove it. Let's write it again. 0 shift 1 2 something something something, 1 shift 5 1 2 3 4 4 5 1 2 3, then 3 4 5 1 2. Okay, in if I want to make it 1, it will take 0 operation. If I want to make it 2, it will have 2 operation because 1 2. If I want to make it 1, it will have 3 operation because 3 2 1. It's already, and it will take 2 operation. Sorry, 1 operation actually, because this isn't our operation. I think that is the solution. Let me verify. Okay, 1 0 0 1 0. Okay, in first operation I'll gonna go 0 1 0 0 1. Okay, in first operation it will gonna be 1 1 0 1 1. So in one operation it works in 0. It also works in one operation. It doesn't works 1 2 3 4. It's already 1. It also works, so that's true. So I'm not getting that one in third operation. Okay, here's the solution. So one gonna get the value from back, 1 5 4 3 1, and 2 are gonna get 1 2. Okay, it goes in a reverse order. But problem is how I'm gonna solve it actually. I didn't think about that. Let me take the input at first. Okay, I know the closest one. Okay, if I do something like 5 4 3 2 something something, what's the closest one from 1? How many distance? Distance is 0, so it will take 0. Closest is 1. Okay, that's the point. Okay, it was train. Zero, 1, 2, 0, 1. I guess I'm right. 5,000 people have submitted. It's not even 30 minutes. Okay, it will pass. Recently, my contest aren't going that well. You have n coins with uh, denominators 1 to n, and your and then natural number k. You also have a bag which is initially empty where you can place coins. You need to perform exactly k action. In each action you take one coin from those you have left and put in your bag. After that you can no longer take that coin. Okay, at the same time you have a cat that loves even numbers, so every time the sum of the demoni demoni de denominators demon denominators of the coins in your bag becomes even, your cat em- empties the bag, means it takes all the coin to place known only to it, and the bag is empty again. Note that the bag is emptied every time the sum becomes even during the process of adding coins, not just at the every last moment. uh, okay, let your score be the sum of the demon of the coins in the bag. Your task is to perform k actions such that your final score is maximus. Find the answer for all. Okay, final score is maximus. I'm a little bit confused. Uh, okay, let's see some. In the first test case, you have coins with 111 k equal to 1. In this case, the sum of the denominators in the bag is 1. What it means? Denominators. সম্প্রদায়.
Denomination.
Okay, a recognized autonomous branch of Christians culture. Okay, you have n coins with denominators and a natural number k. You also have a bag which is initially empty where you can place coins. you need to perform exactly k action. In each action, you take one coin from those you have left and put it in your bag. After that, you can no longer take the coin. The same time after the same time, you have a cat that loves even number. So every time the sum of the denominators of the coins in your bag becomes even, your cat empties the bag, meaning it takes all the coin to a place known only to it, and empty. Note that the bag is emptied every time the sum becomes even during the process of adding coins, not just at the very last moment. Okay, let your score be the sum of the denominators of the coins in the bag. Your task is to perform k actions such that your final score is maximize. Find the answer. That word is throwing me out. Okay, k equal to 1. In the first test case, you have coins with denominators 111. K equal to 1. In this case, the sum of the denominators in the bag is 1, regardless of the chosen coin. The final score is 1. K equal to 2. In the case, k equal to 2. K equal to 2. In this case, the sum of the denominators in the bag is 1, regardless of the coin chosen. When the score is chosen, the sum will be 2, regardless of the coin chosen, and the bag will be empty. The final score is 0. Okay, k equal to 3. In this case, when choosing the final two coin, the sum will be 2 and the bag will be empty, after which the sum will be 0. When the third coin is chosen, the sum will become 1. Okay. In the second test case, you have a coin 1 2 3, k equal to 1. In this case, if you chose the coin with 2, the bag will be emptied and the final score will be 0. If you chose the coin with 1 or 3, the final score will be 1 and 3, representing the maximum score is 3. Okay, k equals to 2. In this case, when the chosen two coin 1 and 3 in the array order, the sum will be 4, after which the bag will empty. Okay, I think I got the question actually. Okay. Okay. Okay, so it depends what's the last maximum odd value I can take actually. So 1 2 3. If I take only 1, I can take 3 as a maximum. For two values, I can take 1 and 3 and 2. It will gonna from a odd in the end. Okay, because odd plus all even is always odd. Then 0, because the full sum is even, so it's not possible. Okay, let's check out this one. 4 1 3 1 2. Let's sort it out. 1 1 2 3 4. Let's divide the even and odd. 1 1 3 2 4. Okay, so for 1 choosing, I can answer is 3. For 2, answer will gonna be 3 and 4, 7. Yeah, 7. For 3, I can take maximum odd. um, mm, how many even I have, how many odd I have? Number of odd is 2, number of even is, sorry, number of odd is 3, even is 2. For 3 I can easily take 3, this 3 equals to 9. For 4, for 4, if I take more than one odd, I have to take them as a pair kind of stuff, or I can take the maximum as maximum. Okay, maximum odd. I can't take any maximum even. So 4, I'll try to take this 3, but 3 is impossible. So 2, then this 2. So 7, 4 is 7, yeah. Then 5, this 2, and so 9. So for odd value, always the maximum odd is always useful. After that, I'll try to pair them up in some way. Pair, yeah, I'm gonna count the pairs. Then I'll take the maximum number of even. Yeah. Okay. Let me think about the time complexity. And time complexity might be pretty high. So I have to take some kind of prefix, some kind of stuff. Okay, 3, 1, 1. Odd value is only useful if for how many are there, those. Okay. I'll have to have one odd maximum. Then I'll take the maximum prefix sum of the even, or suffix, whatever you say. Then just depending on the number of odd remaining odd, if there's a even, then okay. If the remaining is even, I'll try to decrease one even number and make the odd. I'm actually gonna create a suffix sum. Let's make a prefix one. Okay, I don't need odd, I need even. That makes equal to 0 if okay, there is a problem. There can be two possibilities. One is I'll take this two odd and make it 0, or I can take one odd. No, yeah, I can take one odd from here and ignore one even from here and just take two odd from here by making them 0. Eventually I'm taking this one or this one. Okay, I can't take this whole thing. That's not possible. That will make 0. How many extra pairs are there? I have to count that one. If need is greater, If the value is odd, I have to sacrifice one value from the end. It might get wrong. Okay, let's do it from the beginning. 3, 7, 3, 1, 1. And let's say there is 2, 4, 4, 4, 2, 2. Let's take 4 odd. Okay, 4 odd and 5. So I'm gonna take this one. So always this one. So I can take at most 3. Then let's say it becomes 1, 2, 3, 5. So I'll take this one. Let's say I've run out of option. 5. Then I have 6. So I'll take this one. So it's a problem. So I'll just take one less and take this two. Let's do something else. Where's the variables? Y less than while j less than ev and c1 plus c2 less than I. If those happens, I'm gonna do something like, okay, it's E. If those happen, I'm gonna do C2 plus plus and J plus plus. Okay, then let's say those are not still equal. One, two, three, four, five. Then let's say I've taken this one 6. So that's a problem. So 6, it will go 1 back, it will be 7. 7. 1, 2, 3, 4, 5, 6. It will be still 6. I think it should work. K less than O and C1 plus C2 less than I, then C1 plus plus and K plus plus. If C1 mod 2 equal to 0, I'm gonna do something like C2 minus minus C2 minus minus and to C1 plus plus. Okay, if that's possible, then I'm gonna do. If K plus 1 less than O and C J minus 1 greater than equal to, if that's 0, I'm gonna do J K plus plus J minus minus and C1 plus plus C2 minus minus. Otherwise that should be okay. Otherwise it should be okay. If C1 mod 7 and 1, then just C out prefix J plus mx, else C out 0. Okay, something is still wrong. This case. 1, 2, 3. 1, 2, 3. This one. Okay. So if I take 4 2, then 3 1 1. So prefix sum will give 4 6. Okay. Then I don't know. And it will gonna still same. So what was the answer? Answer was 3 3 3 3 3. Okay. It got 0 0. Prefix of 0 0. 0 0. Okay. I think I should shift the prefix. Okay, I haven't created the sum of the prefix. Three seven. Okay. There's a not pro bad timing. 3000. Okay. It will gonna get SC, I guess. Fibonacci big brook. Brothers get S. It is simple 2-pointer, but bro, too many test cases. You are given a directed graph consisting of n vertices and m edges. Okay. 3500. Okay, if I do D, I'm gonna get a positive delta. Okay, you are given a directed graph consist of n vertex and m edges. Is vertex v corresponding to a positive integer a u? Count the number of distinct simple paths consisting of at least two vertices such that the sequence of number written at the vertex along with the path from a generalized Fibonacci sequence. In this problem, we'll consider that the sequence of numbers x0, x1, xk from a generalized Fibonacci sequence if x1, x2 are arbitrary natural number, x1 equal to x. Okay, adding both Note that the general Fibonacci sequence consists of at least two numbers, since the mm, you are given a directed graph consisting and vertices and edges. Each vertex v corresponding to a positive integer au. Count the number of distinct simple paths as consisting of at least two vertices, such that the sequence of the number written at the vertex along the path from a general. The sequence consists of at least two vertices, that the sequence of the number written at the vertex along the path from a generalized Fibonacci sequence. In this problem, the test case contain multiple. In the first test case, one connects to two, one connects to three, two connects to four, four connects to three. Okay, and one is three, uh, two is four, three is three, six, four is six. Okay. Answer is 5. Always, I think I've done a mistake. 1 is 3. Okay, those are same. Okay, answer is 5. I can get 1, 2, 3, 4, 4, and I can get 3, 3, 6, if I'm not wrong. 1, 2, 1, 3, 4, 1, 3, 4. Yeah, I was right. Let's think it as a tree. Too many. Okay, let's say I have 0 here, 1 here. So it should be 1 here. It can be 1 here. Okay. I'll always go from the minimum value. Always start from the minimum value. It's some kind of DP for sure. DP on tree. But problem is the graph can be really complicated. Let's say 8. Let's say this one has 0, 3, 0, 2, 3, 2, 3, 5. And 2, 1. Let's put 3. Number of element is 0. Number of element is 1. They are in a sequential order. Three, so let's say 1. Then 2 minus 3, 5. If I search from a single minimum value, 2, 3, 5, then it got a smaller value, so it will end. Then I'll go from the next minimum value. 2, 3, 5. There's 3. So 1, 2. I think that might be a good solution. 1, 1, 1. I think it's a lame example. It might be a lame example, not sure. Okay, so search from the smaller one, this one. So 1, then go to 1, so 1, because I'm saying the previous value is 0, so 1. I'm saying anything. Okay, 1, then 1 plus 1 is 2, then not valid, not valid. So total is 2. If I enter in a visited path, it will gonna put the maximum value in here. Yeah, then I'll search from another one. It will give me the answer of this one. So just reverse DFS. Answer 1, answer 2. So answer is 2. Answer is 1 plus 1. For that one, I'll get plus 1 again. So that's 2. And for this one, I'll get 0, 1, 2. So total answer is 2. Then from here, I'll go to here. I can go to here. If I go here to here, so I'll get 1, because it will gonna give me 1. If I go here to here, it will gonna give me 2. So total is 3. So answer is 5. In which test case? Second test case. Answer is 9. Answer is 9. Oh, it can also take from here. From the maximum value, I'll go to a path and set it as 0, it as 1, it as 2. Then I'll go to next one. It okay, it has more uh, paths, so I'll go to here. So 0 plus 1, 3, and it will go to here to here. So 0 plus 0 plus 1 plus 4, and it will go to here, but it doesn't matches, so it will not gonna work. It will go to here to plus 1, so plus 5. It gets 1 to 1, 1 to 1. It gets 1 to 1. It gets 1, 1 to 2. It gets 2. The answer is 2 here. 1 to 1. It gets 2, 1. No. 1 to 1. Actually, I think store 1 here. I'll see. I'll store valid sequence. Let's say it's another 3. Yeah, 3. One, one, two, three. 3 values is always normals, but I have extra. This one extra 1, this one extra 2, and this one also extra 3 extra. If I have length of 1, 2, 3, 4, 5, length of 5, I can say 1 is total for this one 1, 2, 3, 4. For this one 3, 2, 1, 0. Total is this much. Okay, total is this much. Depends on the length. The total answer is this one. Okay, so what's the length? From here length is 1, from here length is 2, maximum length is 2. Okay, maximum length is 2. So this section gets maximum length of 2. 1, it gets 0, 1, 2. Okay, 0, 1, 2. Then I search from here. No, I search from the next path. This, it gets this one. So 0, 1, again 2, so 4. And from this path I get only 1, so 5. Total 5. Total, actually not total 5. 2, 2, 1. Then this value is done. I've already visited this one, this one, this one. So answer will be 1 plus 2, 1 plus 2 plus 1. 6, 7. But the answer is 9. Answer is 9 because I can take this one. Okay, this path isn't visited yet. From here to here, from this value I can go to here or here. If I go to here, it's non-valid. 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 That's non-valid. 1, 1, 1, 1. But this path is valid. That's why it gets 2. It gets 2. So plus 2. 9. I know how it works, but I don't think I can solve it. 3000. Caret isn't working. Let's see problem E. You have n elements. Each of those elements have a natural value ai, and the natural removal cost is ci. You need to remove all element exactly one except one, playing the minimum possible cost. Paying the minimum possible cost. To do this, you perform the following operation n minus 1 time. In one operation, you choose two adjacent element and remove the one with the smaller value. For this operation, you pay the removal cost of the least expensive element among the two. If those two elements have equal values, you can remove either of them, paying the removal cost of the minimum of 2 in the term of removal cost. After removing an element, the element to the right of the removal shifted by one position, leaving no gap. Okay, you also have n zeros operation and zeroing operation for removing cost of the array. After the I zeroing operation, the removal cost of the element with index pi becomes 0. It is guaranteed that all pi are distinct. You need to solve the problem for the original element as well as after each of the zeroing operation. Okay, it's it's harder than D. Okay. Normally, interactive questions are easier, so I thought if D was an interactive one or something, so just gave a try. Okay, carrot isn't working. Most probably getting minus because solving 3 isn't that great. 4,000 solved, so that's that. 5,000 solved. 1,000 D solved. Mhm. 2 2 value of n is 2 if 5, so that's large. I can store 1 to 1, and from here I can do 1, it connects to this one, so 1, it goes to 2, it also connected, so plus 1 plus 1 plus 1 plus 1, then it gets plus 2 added, then plus 1. Okay, then it goes to this one. Actually it gets 1 for this one, it gets let's have 1 3. I need 4, but I don't have 4, so it will gonna disconnect. Plus 1 0 plus 1, then it goes here, it works for only for itself, so from it once it takes 2, just takes 2 and store it inside it, and carries out 1 and goes to here. If this element and this one previous both are same, I can't think of anything. If it was some kind of tree, you are given a directed graph consists of n vertices and n edges. Graph is directed. Is it acyclic? Simple path. Count the number of directed simple path consists of least 2 vertex such that, okay, it's a directed graph. One, 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 two. So this one valid, it's not can doable, and this one valid from this one and one. So it gets 0, 1, 2. It gets again 1. It gets 0, 1, 0, 1. So answer is 1, 1, 3, 4, 5, 6. 1, 2, 3, 4, 5. Oh, there is a path. So if I visit from here, it will do 0, it will do plus 1, it will do, and it will go here. It's not connected. How can I parents 1, current 1, parent 1, parent plus parent equal to current value. So that's true. Parent 1 1 1. So that's not true. That's not true. That's not true. So it will gonna reset and give us 0. It will gonna reset here and it will go to here. It will gonna reset here. But this value is already visited, so it will 0 plus 1. Here is a reset, so 0 plus 1. Done. This value is okay 0. Then it will gonna go to here 1 1. It makes sense, so it will give me 0. It will have 1. It will have once 1 and another 2, and it will gonna get back its value. That's 2, and those are disconnected. So 1 2 3 4 5 6 7 8. I don't think I can solve it, but let's try a DFS. N comma M, I guess. 0 1 2, and for if I connect to the second one, okay, if that's connected or not connected, does it doesn't matter, I guess. It should be inside the loop for sure. DFS part already, so I'm damn sure it will gonna give me a wrong answer. Zero 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 zero. Okay, I didn't call. First 0 0 1. Still 0. 0 0. Parents.